In this video, I will show you how to translate an argument into logic symbols and then decide whether it's valid or not using a truth table. So the argument we have has these two premises and a conclusion. So the premises are, I can either drive or take the train. I refuse to drive, so I will take the train. So we're assuming the premises are true, and we want to know, do they then imply the conclusion? So we're going to try to decide that using a truth table. So first we'll translate. Let's let I can drive be the letter D and I take the train be represented by the letter T. Then the first premise is really just saying D or T. I will either drive or I will take the train. Then the second premise says I refuse to drive, so I'm not going to drive, so not D. And then the conclusion is I take the train, T. So that's translating that, what this is saying, into just logic symbols to make it a little easier to work with. The argument is then, assuming these premises are true, assuming that we have D or T and not D, does that then imply T? Given D or T and not D, does that imply T? That's the argument. That's what we're trying to decide. So our variables here are D and T. And so we're going to look at all the possible cases for D and T. And to prove this argument here that we have, we need to know what the truth values are for all possible cases. So we have D or T and not D. Does that imply T? To prove this, we have to also know, to look at the truth values for this argument, we have to know the truth values of not D, the truth values of D or T, and the truth values of this AND statement here. So we need to know the truth values of not D. We're going to look at the truth values of each part of our argument. D or T and D and T, D or T and not D. Okay, so all the possible cases for D and T are where both are true, just D is true, just T is true, or both are false. That's all the possible cases for I drove and I also took the train, I drove, I took the train, or I didn't do either. Possible cases. Okay, so not D is the negation of D, so its truth values will be the opposite of D. So if D is true, not D is false. So that's why not D is false in both these cases. Then if D is false, not D will be true. So these cases, not D is true since D is false. D or T is true if one or the other or both are true. So here, looking at D and T, both are true in this first row, so D or T is true. Just D is true, but D or T will be true because at least one of them is true. Here in this third row, D is false, but T is true. So one of them is true, so then D or T is true. But here, both are false. So D or T will be false in this last row here. So those are truth values of D or T. Now we have the truth values of D or T and not D. So we're looking at the column with not D and the column with D or T. We're comparing those. Okay, an AND statement is only true if both parts are true. So here, both parts are not true. Not D is false, so then the AND statement is false. Again, both parts are not true. This not D is false, so the AND statement is false. Both parts are true, both parts of the statement, so then the and statement is true. Only not D is true here, so the and statement is not true here. Okay. Okay, so now we have the truth values of this, and we have the truth values of T. We're going to use those for the truth values of this conditional. So we want to look at, we're focusing on the truth values of T and the truth values of this part here. Okay, for a conditional, we have the antecedent and the consequent. This represents our antecedent. This represents our consequent. Well, in general, if you have an implication where P implies Q, remember the only time the implication, the conditional statement was false was when P was true and Q was false, when the antecedent is true and the consequent is false. So the only time this will be false is if this antecedent is true and this consequent is false. So we look here where the antecedent is false, that doesn't make the conditional false. We saw so this conditional will be true wherever the antecedent is false, right? These are false. The conditional is true because whether or not if the antecedent is false, that doesn't make the conditional false. It's only when the antecedent is true and the consequent is false. Here we have the antecedent is true, the consequent is true. So therefore, the conditional is true. If the consequent had been false, then the conditional would have been false. Okay, so the truth values of the argument are all, for all cases, true. So when you get all true, this is called a tautology. That means that the argument is valid. If you get a tautology, then you know the argument is valid. That means that the conclusion does follow from those premises being true. So I mean they are true. Okay, we could also decide the validity if we recognize what form of argument it is. It could be a common form of valid or invalid argument. And this argument form, P or Q, not P, therefore Q, that's actually this common form of valid argument called disjunctive syllogism. Because it is an example of disjunctive syllogism, then the argument is valid. What this means is if you can translate the argument into logic symbols and recognize if it is a common form of valid or invalid argument, then that's a quicker way of deciding if the argument is valid or not. You don't have to do the truth table if you can see that it's a common form of valid argument, in this case disjunctive syllogism. Then you know, you could have said, oh, that's disjunctive syllogism when you saw the logic symbols of the argument and just said, okay, it's valid because of disjunctive syllogism, and you wouldn't have had to do this whole truth table. So something to keep in mind. It's like a shortcut to deciding the validity of the argument.